All right, so this is our episode club. If you haven't followed me before, I know kind of the advertising for this week's session got a little bit crazy in a good way on Twitter. But if you haven't been here before, unfortunately, this is our last regular weekly episode club. Now, that doesn't mean that I'm going anywhere anytime soon. In fact, you probably will find me more on Twitter here. But we were doing weekly episode clubs at this time every single week, breaking down the science behind like 2 or 3 episodes or a movie or something. And it ended up being a lot of work for me in a great way, But in terms of time management to try to balance my, the paying, it's not that, you get what I mean. It was a lot of work. So, with a lot of, but Doctor Who 42, first of all, excellent username. Love it. Happy you're here. You are still going to find me. I'm still going to be doing my Astronomy 101 classes on Fridays. And then I'm still going to be doing my Star Trek Sundays with Samantha, where we review Star Trek episodes. And then throughout the week, probably Monday, Wednesday, and Fridays as well, I'm going to be randomly streaming games. There's been a big informal petition to get me to do Star Trek Online. So that will probably be happening starting next month in lieu of these. Now, that being said, if I watch a movie or an episode of something, or someone messages me and says, hey, you need to check this out, and it's got amazing, cool science in it that I want to share with everyone, we will do an episode club on that. So it's not totally disappearing. It's just not going to be a weekly thing anymore. So yes, there's going to be great stuff. Thank you. Hi, Brad. Yes, cheers. Raise a glass. I do actually have some libations, because normally I go an hour for these, and this time we're just going to go until we drop maximum 2 hours. I'll probably drop before then. It's really hot up here, and I'll probably run out. But cheers. Yes, so I am very excited to do this. Avenue 5 came out earlier this year. I am a huge Armando Iannucci fan. Huge. If you don't know me, haven't seen me before, I did my PhD in Glasgow. I lived in the UK for 5 years. And Armando Iannucci's from Glasgow, did The Thick of It. Brilliant show, as well as a bunch of other just amazing, amazing stuff. And then came over here, started, produced Veep, and then Avenue 5. And I could not believe that I was getting an Armando Iannucci show starring Hugh Laurie that was intentionally, the entire plot is a cruise ship in space, and gravitational dynamics is dictating the entire plot. So it's pretty fabulous. Good. I'm so glad. Hi, Dipe. No worries. D&D is important, so no problem at all. And yes, Andy, I'm happy you're here. Hi, Kuro. Happy to see you as well. This is going to be fun. This is going to be fun. Avenue 5, I get that this sense of humor is not for everyone, and that's okay. But it is very much my sense of humor. Just ticks all the boxes for me. So the way that we're going to do this today, like I said, I'm not going to hard stop at an hour, and we'll go through this. Essentially, I'm going to break it down into more categories. When we've done the episode club before, we've done like one episode and then another episode. What I'm going to be doing now is talking about the whole season and the different science aspects that are peppered throughout the season. So definitely hang in here from that. Oh, hi, Billy. Oh, hope traveling went okay. And yeah, I agree, Doctor Who. There's so much potential. There's so much potential. I'm so excited. Okay, so what I'm going to talk about first is we're going to talk about the general path, what this story kicked off. And I know Daib said you haven't seen it. Maybe some other people haven't watched it. So I'll try to give a little bit of a background. Obviously, there's going to be spoilers. It's still worth watching because it's not about the plot. It's about the comedy and the characters and the acting. It's all amazing. But I'm going to be talking first about the path around the solar system, the idea of gravitational slingshots, the time dynamics. Now, I ended up doing a lot of math today, and yesterday, a lot more than I had planned. We may end up doing some, maths. I did break that. There's still a few things. I still say herbs. I still say There's some stuff that still sticks, but unfortunately, when I came back to the U.S. and went into engineering, math came back. So, but I agree, because it's mathematics, not mathematic. So I'm on your side. It's a habit I can't break. Okay, so we'll do the path around the solar system. Then we're going to talk about the artificial gravity, how that works on the ship. Then we're going to talk about the comms delays. Then we're going to talk about the gravitational orbits that we get. We're going to talk about the wetsuit, and we're going to talk about what it's like to die in space. We have a lot to get through. Oh, and we're also going to talk about Newton's third law. So even though we're going to be alluding to that stuff, but I will kind of summarize at the very end, like what happens at the very, very end of the show. We'll do that last. So because obviously it was a cliffhanger, this is going to be a season 2, and there's going to be more science. I also need to caveat that I did not work on this show. I work on Star Trek. I did not work on Avenue 5. Would I love to work on Avenue 5? Yes. Am I transitioning my career to work as a show writer and hopefully move up that chain? Yes. When people ask which shows I would love to be a staff writer on in my little new career field outside of Star Trek, I would be saying Avenue 5 is definitely on that list. So that's all the context here. I have only scienced this as a fan and gleaning what information I could from the internet. And I kind of gave a shout out today to Simon Bowles, who was the production designer for this show, because the only technical information I could find was from interviews that he gave. So I really need to thank Simon for giving interviews and then those interviews being posted online, because otherwise I would have been flying literally in the dark with this, just pulling off of the show. But I did manage to get that. Oh, that's awesome. Yeah, Doctor Who. Unfortunately, we can't share links here unless you're a mod, but I would definitely share that on my Twitter. So find me there, message me on there, and I will be happy to share that as well. So thank you. Okay, so the overall thing, it's a cruise ship in space. It's a cruise ship in space. This is set like, what is it, 40 or 70 years? Right off the bat, I knew there was going to be something that I didn't write down. It's set in the future when there's a cruise ship in space. And they are on their way. They're essentially, the cruise path goes to Saturn, loops around, and comes back to Earth. Yes, thank you. So 2054, so 40-ish years, in the future. And there are 5,000 people/passengers on the ship. Thanks, Carlos. I appreciate it. That again is also unclear. They talk about the number of people. They say 5,000 bodies. So I'm gonna go with 5,000 because it's also a nice round number. And whether or not they're counting the crew in that, I feel like that's an entertainment design. But we're just gonna use 5,000 people. So I looked up some stuff about cruise ships, particularly ones that are 5,000 capacity, which are kind of about the maximum that we have right now. The sort of average that you'll find, they're typically the Royal Caribbean cruise ships. They tend to be about 5,500 capacity with double occupancy. I learned so much about cruise ships this week. It's crazy. Now, again, if you don't know me, I do work with Star Trek, and the only cruises I've been on have been as a science speaker on the Star Trek cruise, so that's my only fundamental knowledge for this, which makes Ethan Phillips playing an astronaut who's giving science talks on a cruise particularly fantastic. Just saying that. All right, now, it's amazing. It's a great experience. So, trying to figure out the mass of this ship. Let's just break down. Okay, it's a cruise ship in space. It's got 5,000 passengers. What could that be? Now, when I first started looking at all of this, the numbers I was getting was about 225,000 gross tons. That threw me so much through a loop. And I went down a rabbit hole of, not joking, a couple hours trying to learn what gross tons are when it comes to ships, because I am a astrophysicist and an aerospace engineer and have nothing to do with the Navy or ships or things that float or anything like that. That was kind of the volume capacity, but we're in space, so scratch that. I just looked up the dead weight of cruise ships, and approximately what I got was about 100,000 metric tons. So that's 100 million kilograms. And there's a lot. That's a lot. That's a lot. Very nice. Now, One of the things that Simon Bowles commented on was that they made this whole ship 2 miles long, which is really long. And then I looked at the art for this, and I'm actually going to pull up some of the art here. So this is the ship design as far as I was able to find. Now, for me, what this looks like is that we're actually kind of, yeah, 2 miles. But if you look at this, it kind of looks like the cruise ship is on one side, and then the entire rest of it is an engine. That we have this propulsion, some sort of technology. There's doesn't look like living quarters, is what I'm trying to say. So I'm just going to use a mile, and I hope you're all good with this. You better be good with this. Now, they do talk a little bit about the lower decks aspect. That there is obviously there's a crew. I'm going to say, obviously, I know if you haven't watched the show, I'm not being condescending to you. I'm just in the context of the show. But they have like a fake crew on top who are all actors and they don't know what they're doing. And then they have a real crew, like the lower decks type crew that's all grungy. And that's what my background is right now. And they're in the not shiny part of the ship, but they're physically below the bridge. And so I'm not counting that as like this far right portion of it. I'm counting it as actually part of the shiny bit cruise ship. Because too, when you look at actual cruise ships, they have the nice shiny part up on top. And then there is bowels to the cruise ship. They're typically below the water, but in this case, we're in space, so it's fine. Yeah, but, and by all means, please feel free to throw Avenue 5 quotes in here because I giggle about quotes constantly and I love them. So when we're talking about the ship, we had to figure out what the mass of this ship was. Now, what I'm going with is that we're just going to take the order of magnitude because I'm an astrophysicist and that's what we care about. So we're on the order of magnitude here. So we're talking about 100,000 metric tons. Whether it's 100,000, 200,000, it actually doesn't make that much of a difference when we're kind of doing the math here because we're at the order of magnitude level. You know, we're talking about times 10 to the, what do I have? 1, 2, 5, 8. We're talking times 10 to the 8 kilograms, so it's a lot. Okay, but the big issue, the reason I'm breaking this down into like 1 mile versus 2 miles is because I needed to figure out how much weight there was of air. Because we were talking about this last night, my partner and I, when we were finishing up the season in a rewatch, and we were thinking like, okay, how much does this ship actually weigh? Like, what's the mass of it? And we could take a normal cruise ship there, but normal cruise ships are steel. They have to float in water. They're designed, they can be heavy. They displace a lot of water. A cruise ship in space doesn't need to be heavy. In fact, it's probably better if it's not heavy. However, a lot of the design and the fact Doctor Who brought this up at the beginning that it was actually a cargo ship that was bought by the Judd Corporation and retrofitted, the fact of that means that, you know, it could be heavy-ish. And we can actually, if you eliminate kind of what the heavy stuff would be that you would want to reduce for in space, like using different materials, you're probably going to earn that back by the fact that you have to self-contain and pressurize with air in this ship. And air is not insignificant. You know, we have 14 psi, pounds per square inch, is our sort of atmosphere. And that weighs something. So if you've pressurized the entire ship, there's additional weight to it. So I kind of counteracted the weight of a normal cruise ship with the fact that we would have to weigh the air on the ship as well. So I hope everyone's okay with that. But so adding up the weight of the cruise ship, the mass of the cruise ship, how much stuff there is, plus the air, plus 5,000 people on the ship, we got to about 110,300 metric tons of mass. Unpleasant. Unpleasant. It's a lot. It's a lot. I figured out the air volume kind of, again, by estimating the size, and that's where the mile part brought in. That's where I cut down the 2 miles into 1 mile there. Now, another funny thing that happened as we're talking about the air volume in this show is the beep. Was that episode 7, I think? 6 or 7? There's just a beep that keeps going off, akin to like when your fire alarm is running out of batteries, and it'll mess you up. And it messes a lot of people up on the show. And they think that there's an oxygen leak. So that's the link with the air. Well, what they find is that there was a baby who was born on board. And they do find out, hi, Uncle Mel, yay. They find out that this wasn't an oxygen beep, that this was actually a recalibration beep because there was a new passenger brought on board. So there was a 0.02% increase in the ship's population. We went from 5,000 to 5,001. But 0.02%, that's about, I've rounded there, so that's about fine for the increase in population. However, newborn infants, I scienced the crap out of this. Newborn infants have a 20% air capacity to adult humans. So it's still 20% of 0.02%. So we're talking about only a 0.004% increase in O2 consumption with a newborn baby on the ship. That's a hell of a well-calibrated air filtering system on the ship to be able to notice that much of a difference. And obviously the weight of the ship is not going to change because this is only 4 weeks after they took off, so the baby hasn't grown that much, and there wouldn't be a weight differential from that. It's really just oxygen consumption, and the oxygen consumption here only increases by 0.004% for a 5,000 population with a newborn baby. Thank you. Was quite proud of that one. All right, I learned so many new facts too from this. Now, so that's kind of how we figure out the weight and the air of the ship here. Yes, exactly, Mutant Bob. Thank you. The mass is all a closed system. It's entirely a closed system until later. But for the most part, it's an entirely closed system, and it's super, super massive. And you do want to keep all your mass on the ship because actually orbital dynamics are incredibly difficult to maintain and sustain, as we actually are able to science out in this show. When they said that this was an 8-week initial journey, so it's an 8-week journey to Saturn and back. They're basically going to go to Saturn, slingshot around, and come back. I was thinking, that's freaking fast. That's really fast to be able to do that. I wasn't sure how fast, so we mathed it. Now, a tricky part here, and something that, okay, I will say, I am going to say up front, and I will repeat this again. Avenue 5 is not perfect with the science, as I found when I started applying numbers to this. And that's okay, because it's a brilliant show, and we're here to have fun. We're not here to poke. I mean, we're here to poke, but in a loving way. And yeah, there are some science flaws in this show, and that's okay. It really doesn't matter at all. But it matters to us because that's why we're here and that's what we're doing. So the distance between the Earth and Saturn changes throughout the year. Again, orbital dynamics are really, really hard. Now, Earth goes around the sun faster than Saturn does. Saturn goes around once every 27 years. And currently, it's 851 million miles away from Earth. But if we took off right now, it wouldn't be an 851 million mile trip because Saturn would be moving as well. The closest point between the Earth and Saturn is 740 million miles. I don't have these all memorized. I have notes. I'm not that kind of genius. So I'm saying let's just average 800 million miles. Let's just say it's 800 million miles trip. Mutant Bob, that's funny. I like that. Yeah, Saturn is in no rush. And side note, one of my favorite things in life is the return of Saturn crisis, that when everyone gets to 27, you kind of have a bit of a life crisis, just a little life crisis about your career and what you're doing. And it's called the return of Saturn crisis because Saturn has made it back to the point where it was when you were born. But that's astrology. That's not astronomy. I just like it because I also had a 27-year-old crisis. All right. So let's say now, so we're averaging 800 million miles trip. We're just going to assume that that's the distance. And it's going to take 8 weeks to do that trip. But you got to go there and back again. So in one trip, you're going to go for 4 weeks. You're going to travel 800 million miles. And the speed of that is 5.3 times 10 to the 5 meters per second. That's really fast. That's really, really fast. I did not convert that to miles per hour for our edification, but I can do that right now. Let me see, 10 to 5. Yay, computers. Yeah, that's 1,000,000 miles an hour. So that's really, really, really far. Ooh, thanks, D Starfire. 4 times the speed of a bullet. I like that. So yeah, 1,000,000 miles an hour. That's fast. However, it's not a significant percentage of the speed of light, which was another thing I checked. It's actually 0.0017 times the speed of light, or 0.17% of the speed of light. So you're actually, even though you're going very fast, you're going 1,000,000 miles an hour, you're not going to encounter any special relativity effects of time being different, where we talk about Lorentzian time dilation. If you've heard of this before, like the Einstein twin paradox, where your twin stays on Earth, you travel at a significant percentage of the speed of light, you come back and you've aged differently. That won't happen here. So they're going fast, but they're not going fast enough for that to be a significant amount. All right. I do like that sense of humor too. I appreciate that. Okay. But as what happens, God, I love this show so much. I love this show so much. All right. What happens is an accident. The gravity flips. There's artificial gravity on the ship. It's pointing down, and then it does that, and then it does that again. It corrects itself. However, when it did that, everyone on the ship slammed into the side of the ship. And yeah. Other people can chime in on the Gilligan Island comparison, but you're not far off that. So everyone slams into the side of the ship, and it actually shifts it off course slightly. It shifts it off course by 0.21 degrees. But that is enough in the story to extend the length of the trip from being an 8-week journey. Now I'm going to have 3-hour tours stuck in my head the entire time I do this. But from being an 8-week journey to actually being a 3-year journey, as they said. It's going to be 3 years. That's not good. Now, they throw up a orbital dynamics type gravity slingshot simulator image that I grabbed. And so we'll talk about the stuff that's going on the top in a second. But here's what their image was. And I got this from the production company that did the animation for this stuff. This makes me, it looks beautiful. And then I looked at it as an astrophysicist and I physically felt ill. But with an astrophysicist hat on. Story-wise, it's hilarious. Okay, so they're thrown off course, so they're going to miss Earth. They go back, they swing around, then they go all the way that way. They swing back around again. So they go out all the way to Venus, and then they come and pass Jupiter, which in this image seems to be within the orbit of Mercury and the Sun. The little bit on the bottom there. And then Mars is like off on its own orbit by itself. Obviously, the size and distance comparisons are not, it's not to scale. It's not to scale. And it actually has the planets in not the right order. Venus looks to be farther than it is from Earth. Farther from the sun than it is from Earth. And yeah, screams an astrophysicist. Thank you. Mutant Bob, that's absolutely fair. All right. But we're going to go with it. The other issue is it's not so much the size and distance units here. It's the fact that the planets are stationary. So over the fact of now, you see the days, sort of, they say about 1,000 days. The fact that they have those there, and the planets aren't moving, because remember, it's dynamic. The planets go around the sun. So as those 3 years are happening, Earth has gone around the sun 3 times. Saturn has moved a little bit. They're all in a different position. It's okay. Visually, it's fine. What it's doing is it's showing the gravitational slingshots. And if we just take it at face value, what happened was they got knocked by 0.21 degrees, tiny, tiny knock. They started, that threw them off course, so they're actually going to miss Earth. They're going to slingshot around Earth, send them back to Saturn, slingshot around Saturn, totally miss Earth at this point, go kind of from that, looks like it slingshots around Venus's gravitational well, at the very least the sun's gravitational well, goes all the way back to Saturn, comes all the way back again, and then finally hits Earth 3 years later. Not ideal. So, Mutant Bob, that was a suggestion. That was a suggestion that our good friend Ethan Phillips, the astronaut Spike, was his character. Was it Spike? Yeah, his character's name in that. He just said, well, why don't we flip the gravity the other way and throw everyone on the other side of the ship? But the issue was, he literally says, why don't we just fire everyone at the opposite wall? So you've got the right mindset there. First of all, it wasn't instantaneous. So this happened. They do all the calculations. It appears that at least hours have passed, if not significant fractions of an hour. And they said because they were knocked off course, they missed their window to slingshot around Titan. Now, Titan is one of Saturn's moons, so all of that sounds good. But the, so, yeah, I went down a rabbit hole of momentum and collisions, and I ended up pulling out like grad school level physics books, and I just was like, this is not worth it. Because what's going on, so conservation of momentum, it had, we're gonna do the Gilligan's Islands quotes. Yeah, so the mass isn't changing. The mass isn't changing, but the center of mass has changed, and you do have a impulse happen, right? So the mass isn't changing, but the center of gravity has shifted, and it happens fast, and such that I'm not convinced that this wouldn't actually count as an ugly form of an inelastic collision. But like I said, it's not easy. It seems straightforward, and it's really not. So you have something going on here, and then you have like a shift. You have a dynamic. I am trying to say yes, and thank you. But you have a dynamic movable mass within your major mass, and if that hits the side, that could change. And it is only 0.2 degrees, so it's not a lot. But, you know, I tried, and it wasn't obvious to me how you could justify it either way. So story-wise, we're going to let it go. And 0.21 degrees doesn't sound like a lot. In space, that can actually really screw you up when you're talking about gravitational slingshots and trying to precisely hit a tiny planet in a big space. Space is very, 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 very big, and it's easy to miss things. All right. I mean, Mutant Bob, I'm not far off from perpetual motion machine nonsense, so I do agree. It's a little bit hooey, but I'm not convinced because you do have a force happening, a sudden change. But we also have magical artificial gravity here, so we should let a few things go. All right, so they're extending their trip for 3 years is what they said. But I took that map and I said, all right, if that's the path that they're doing, then they're going from Saturn to Earth in 4 weeks is what the initial plan was. This has changed it to Saturn to Earth, Earth back to Saturn, then Saturn past the Sun to Venus, then Venus past the Sun to Saturn, then Saturn to the Sun to Venus again, and then Venus to Saturn to, no, Venus to Earth. That was it. I added it all up together. You do get about 7.6 times 10 to the 12 meters with all of those average distances between those. And at the speed they're going, which again I calculated to be 5 times 10 to the 5 meters per second, is actually not 3 years to make that distance. It's actually only 6 months. It's only 6 months. Again, remember, they're going fast. If they can just do 4 weeks from Earth to Saturn, then making that trip a couple times is not going to add on 3 years. But that being said, we established that this diagram of these slingshots is astrophysics nonsense, which is okay. So it's an indicator of what's happening, and it could be a partial because they don't show them landing on Earth. And remember, the planets should be in a different position, so we might be able to get away with that a little bit. It does sound like Cyrus, exactly. So, okay. So Cyrus, again, for those of you who haven't watched this, Cyrus shows up and he says, we can make it home in 6 months. I'm wondering if someone did the math on that. And because when I got 6 months, I mean, I ended up with 24 weeks out of that. And I was like, oh, that's 6 months. And because Cyrus shows up and he just says, oh, hi, Mikhail. He says, I can get you back in 6 months. And not because of speed and distance logic, but he says we basically, he says, well, I can get you back in 6 months. And, oh yeah, and then they find out that actually he forgot to factor in 500 lottery winners into the population, and so it actually adds 6 months to the 3 years. So they kind of undo that magical nonsense, which is hilarious. But they do suggest that they can get home in 6 months if we get rid of 500 people's worth of weight. Which is awesome. And exactly, D Starfire. This is why, like, I constantly am. I mean, it's like my job at this point to jump my hat between the science brain and the entertainment brain. And if we had to actually show a diagram of where everything was over the course of 3 years, it's not worth it. It's not worth it. So the only thing that I might quibble with a little bit in that diagram is Jupiter being where it is. But that's it. We'll let everything else go because it works, and the comedy is worth it. Okay, so 500 people's worth of mass to be chucked off the ship. We'll pause there because we'll come back to that at the end. We'll come back to that at the end. It was really funny. They're still trying to figure out everything else that's going on. So we've scienced now the mass of the ship, how fast it's going, how fast it's going, and then what that path would actually look like if it follows approximately the path there. And we got about 6 months, but they say 3 years. We're going to go with the 3 years aspect. Now, oh yeah, and then we also talked about the collisions, the fact that it's like an inelastic, but within the mass of the ship. Yeah. It's obviously not a very straightforward momentum collision equation to be able to do this, if it can be done at all. And as some people have argued, and I don't disagree with, we're kind of on the edge of perpetual motion if you're able to actually do that, because that sounds like that EM drive that is not very scientific. Yeah, Daib, exactly. I like that. It's like throwing a dart and hitting a bullseye 6,000 miles away. Or what was that from the Star Trek Kelvin films, where Scotty said it's like trying to fire a bullet while riding a horse blindfolded or something like that. It's like that. Okay, so let's talk a little bit about the fact that they have artificial gravity on this ship. There's no scientific explanation for what their artificial gravity is. The shape of the ship is not a rotating spaceship, so there's no, and it's able to instantaneously do that and then do that again. So they have artificial gravity. We're leaving it at that. How does it work? It works very well, thank you, except for when it flips and then it flips back again, and that works. Yeah, thank you, Andy, for the correct quote there. All right, so if, like I said, with the collision, I did try to science it a little bit. Let's imagine that they did just have 5,000 people slam into it and it was an inelastic collision. They come at it laterally, they stick. It's a fraction of the mass of the whole ship. So I just was like, well, what if? And it only changed their velocity with the angle they're talking about at 3.6 meters per second. So a very, very small fraction of that. And 500 people are actually only 0.027% the mass of the ship. So the things that they're doing are more good numbers for us to comprehend. I think if they had to actually science the numbers themselves to make this plot happen, it would be a lot of numbers. And I agree, Doctor Who, that that's a underpopulated universe from what we saw here. Okay, let's talk about the comms delays. So the comms delays here this is another... If I have to choose between the science and the story here, I'm going to take the story every single time because they have a 26-second delay between Avenue 5 and Earth. Mars is actually very far away. If you are going to be using standard comms, which travel at the speed of light, Mars is actually... Did I write it down here or in my notebook where I had to do a lot of math? Mars is actually 71 light minutes away. 71 light minutes. Is that right? Is that right? Did I say that right? Yes, I did. Mars is 2 light minutes away. Yeah, Saturn's far. Saturn's really far. Can someone double check that for me? Andy, can you double check that for me? Just type in how far away is Saturn from Earth in light minutes, or how far is 800 million miles in light minutes. Yes, when we're at our closest point between the Earth and Mars, it's 4 light minutes, because we are 8 light minutes away from the sun and Mars is 12 light minutes away from the sun. So at the closest point, it's 4 light minutes. Saturn, 71 sounds big. I wrote that down because I knew it wasn't 26 seconds. I knew it was not 26 seconds. That's the only one I can get. Yeah, 71. All right. It's far. So the comedy in the episode, in the show, thank you. Thank you for checking, everyone. I appreciate that. That still doesn't feel right. It feels right from the number aspect, but from like how far it is from us to Mars, or from us to Saturn. But anyway, letting that go. I always second guess myself when I do this stuff. But they have a 26-second comms delay, so they're technically traveling faster than the speed of light in their communication system. But at no point do they imply that whatsoever. They just say it's 26 seconds. And honestly, it is worth it for the comedy value. It is worth it for the comedy value because it says it's a 26-second delay, so it requires them to wait every single time they say something. And so real-time communication is awful, and they pull that thread so well for the comedy value that, like, if they were doing actually 70 minutes, then obviously they wouldn't even attempt to do real-time communication, so they wouldn't have that joke to play with. Yeah, it might be possible that they've used their subspace comm system, but no, so Mutant Bob, I did think about that. They are at Saturn at this point because they have their halfway home party kind of a few weeks later, or a few days later. And they also talk about the fact that they missed their window to do a slingshot around Titan, and they're visually close to Saturn. So they are, for our purposes, we can say they're at Saturn's orbit or close enough. Yeah, because I thought about that one too when I was thinking about this. But still brilliant. Still brilliant. And again, worth it for the comedy value. So as we've broken this down, we've talked about the fact that, like, the speed they're going, okay. Their collision actually throwing them off course, scientifically probably not. The fact that their distances and their loops and the speed that the ship has, they could probably get home in 6 months. Again, space is very, very, very big. So we're very much oversimplifying that, just using the diagram that they said was the path that they would be able to take. If we compare that to the distances, 6 months seems reasonable, but that could just be a snapshot of a 3-year trip. So, the comms delays, scientifically, that's faster than the speed of light. There's no way that they'd be able to do that in 26 seconds. However, let's put the... Oh, hi, Chad. We're talking about Avenue 5. Show that came out earlier this year about a cruise ship stuck in space. It's hilarious. Comedy. So the 26-second thing doesn't work, but it works for the comedy. So if I'm going from science to story standpoint, I'm going to be so far on the story side because it's hilarious to watch them do real-time comms. And as we've talked about before in the, was it, God, what show was it that we were talking about this? Was it Stargate? There was a show we did an episode club recently for where they did manage to also convey real-time comms effectively. The delay, and yes, the glider, thank you. That there was a delay in communications. Thank you. Yes, that's what it was. And it's hard to do. It's hard to convey to people that you can't do real-time communication in space. You can try, but space is very big. And speed of light still takes time to travel through space. And, oh, that's right, they were going 1,000,000 miles an hour, so brilliant. That's so cool. I love that. Okay. So I padded up front kind of the basics about the show and some of the details there. And we've bashed it a little bit, and I feel bad because I love this show. I love this show. And they threw some numbers around that sounded right, but when I actually tried to do the math, didn't quite check out. But that's okay because it's hilarious and we still love it. And yeah, Jonas Smith, they're all fabulous characters. I'm gonna transition into some of this other stuff where actually they did some very, very, very good science here that I love. Now, again, you're still not going to be able to convince me that it wasn't brilliant to have this be the storyline. That you have an artificial gravity shift, throws bodies up against the wall, throws them off course, and extends a cruise ship in space. Hilarious premise. And very much just as The Martian kicks, you know, their not exposition, inciting incident is not scientific. Without it, you wouldn't have a story. This inciting incident may not be scientific, but without it, we don't have the story. So we approve it and we move on. And some of the other stuff that we have in here is fabulous. All right. Now, because we're kind of at a halfway point here, I will mention that, oh, thank you, Exoration. I will mention that we have played this before when we were talking about a show or a movie that is not Star Trek. We play Spot the Star Trek. So, if you found any Star Trek references, and Ethan Phillips does not count, who played Neelix in Star Trek Voyager, and he is brilliant in this show. A hole's a hole. Sorry, that was not an appropriate joke, but it makes me laugh so much. There is a Star Trek reference in here from within the first 30 seconds of the first episode. There you go, Doctor Who got it. Thank you. Hey, first time finding this. Set phasers to fun. Hooray, well done, everyone. Yeah, we got the Star Trek reference. But yeah, I mean, Ethan Phillips is gold. As I said many times when I was rewatching the show. I love it. I love it. And yeah, I had the pleasure of being with him on the Star Trek cruise in March, right before everything happened. So, love you, Ethan. All right. Oh, thanks for the follow, Chad. Okay, now we're going to transition a little bit into talking about gravitational orbits of the ship itself. So as we established, using some fairly fuzzy math, to be fair. We're talking kind of spherical cow level physics fudging. But astrophysicists are great at this. We established that the mass of the ship could be estimated to be approximately, well, I keep forgetting this. Yeah, 1.1 times 10 to the 8 kilograms. I need to actually write that out scientifically. Times 10 to the 8, woman. All right. I have it just written out, long form. That's a good question, Doctor. Yeah. So it has significant mass. It's big. Yeah, 110,000 metric tons. It's a massive ass ship. I'll put it that way. Now, at one point when the gravitational field, this artificial gravity, shifted, Joe died. Engineer Joe. We never got to meet Joe. Joe dies kind of in the same way Mark Watney almost died, except Joe was actually in space. So, unfortunately for him, didn't make it. Brings up an interesting point that, actually, I'll come back to that. So, Joe gets impaled when the accident happens, and he dies. Apparently, he was the only one who actually knew how to fly the damn thing. Our Hugh Laurie is just an actor. He has no idea what he's doing. And Engineer Joe was the dude that held everything together, with some not insignificant help from, oh shoot, was it Billy or Bobby? Billy, the other engineer. Also brilliant. Also sitting, sitting right behind me. There she is. Yeah, Billy, thank you. Now, so Engineer Joe dies, and they have to have a funeral for him. They weren't expecting anyone to die on this voyage, because it's only 8 weeks. And but they do have Judd's, the CEO. They have his coffin on board, which happens to be 800 pounds because it's made of gold and lead. Yeah. Hey, you're not wrong, Mutant Bob. And it would have been in the backward direction, but you have 5,000 one way. But yeah, that would have actually been physics hitting the ship, an inelastic collision. Not Joe. Poor Joe. So he hits the ship and dies. Sorry, I have to find my calculations for all of this. Yep, there we go. And as they mentioned when they're putting him in the coffin, they said, he is not a light dude. And so I'm going to estimate lowball that comment to being about 90 kilograms. So we have a 90 kilogram dude in a 360-ish kilogram coffin. It's at 800 pounds, gold and lead. So total about 450 kilograms. This whole coffin. That's heavy. That's super very heavy. Now, that's okay, Mutant Bob, no worries. It's a brilliant show. They launch him out. They soft launch him out. They effectively open up the bay. They seem to launch him, and this is going to be important. And then he gets about 4 to 5. I went with 5 coffin lengths away from the ship before he slows down, and he starts orbiting. Oh, Joe. And now they have a coffin orbiting the ship in space. And I hope for those of you who haven't watched this, that should be enough to sell you on the comedy of the show and why I love it so very deeply. So this coffin starts orbiting. Now, I did do the math. Did so much math today. I gave myself so many homework assignments with this. So I said it got about 5 meters away before he started orbiting. Tried to figure out what the escape velocity of this ship would be. It's about 1 times 10 to the 8 kilograms. Wrote it down that time. And let's say, okay, the escape velocity when he was at that moment, when he started to slow down, which again, I agree, is not ideal. Actually, that would be the radius of the ship. That would be from the center of mass. And I did estimate that. We're going to remath this real quick, actually. I know, Kuro, I'm sorry. I know. It is maths. I don't disagree with you, but I have been broken. Rebroken. I got unbroken, said maths for 5 years, and then fell back into saying it, so I apologize. No worries, Dave. Yeah, it's brilliant. I do, you're not wrong, but I'm just crappy pulling this up here. Thank you. I know, I get it. Okay, so we're gonna redo this real quick. Oh god, this is the ugly one. So I'm gonna change this to, let me see. I'm so sorry. This is not a pretty equation to do on a really crappy calculator here. Nope, that is not going to do it. And I have the ship to be about 50 meters wide, so it's going to change that factor by, let's see. Everyone loves when we're doing math real time, don't we? Yay! Yes, we do. Of course we do. Yeah, I see people. I know. Chug, chug, chug. I'm going to do a lot of math and it won't work out and we're just going to blame artificial gravity. You're not wrong, Bob. Regardless, actually, it doesn't matter. So what I had done before was I created the artificial radius to have the escape velocity count, but I screwed that up and I went from the surface of the ship. It should have been from the center of the mass of the ship. So I should add about 25 meters onto it because I estimated the ship to be about 50 meters wide. So I should add 25 meters to the denominator going from the center of the mass. Thank you for the follow. You followed it like the worst moment, so I really appreciate that. Regardless, the escape velocity that I get, whether I'm doing about 10 meters away from the ship or 30 meters away from the ship, is fractions of meters per second. Fractions. So frankly, anything that's slowly moving away from the ship should still be able to escape it. Because even though the ship is massive, it's still not massive enough. It's actually very easy to escape from. And this is important. This actually is a very good teaching moment. I try to find happy teaching moments in these when the science sort of gets a bit hooey, because we still have to give them credit and we still take an opportunity to learn something. We have a very massive ship, right? We said it was 110,000 metric tons. That is more massive than a lot of asteroids or comets that we have tried to orbit, land, go to, you know, all these. You think of 67P Churyumov-Gerasimenko. Still got it. That is not that big. And frankly, it's smaller than Avenue 5. And we landed something on it. And that goes to show how small the gravity is on these, that it's very, very hard to actually land and stay there. And so when we talk about an escape velocity from a cruise ship, it's actually not hard to just fly out of there. I know. I didn't pull a Python. It was a crappy computer. I say crappy ability to do maths. You'll break me. By the end of this episode, I will be saying maths again. So, just, well done. I got peer pressured into saying it. I got peer pressured out of saying it. I can be peer pressured back into saying it again. All right, Kuro, no worries. Happy to have you here. I hope my pronunciation of maths didn't drive you away. Okay, so the escape velocity of this doesn't work. Anything you fly out is going to be able to actually escape. But I do have a counterpoint to this. Because when the artificial gravity changed and the incident happened, Joe was outside of the ship, as we mentioned. Joe felt the artificial gravity change on the outside of the ship. He got pulled away and then got pulled back. That seems to indicate that the artificial gravity field of the ship actually extends beyond the ship, making it appear to have more mass than it actually does. So even though we've artificially made up how much mass there is to the ship, the fact that Joe got pulled away and then pulled back while being outside of the ship shows that their artificial field extends beyond that, such that having that coffin shot out of the way, it's not insane that it would get caught in that orbit because it's not insignificant. So I'm okay with that. Thank you for not hating that. I appreciate that. Because it kind of works. It kind of works. So yeah, so I said in my notes, it's possible the artificial gravity field extends beyond the ship and artificially increases the mass, which would increase the escape velocity, which means you're not necessarily able to escape the ship, even if you're going at a speed. He gets shot out. It's a heavy coffin. Hilariously heavy coffin. 450 kilogram coffin. All right. More stuff gets fired out. 3 people died after the incident from their wounds, from their injuries. We had Mary, and Johannes, I believe, were the 3 people who died. And but they found the mistake with Joe, so they were going to give him lighter coffins. They're going to give them lighter coffins. They basically put them in clear plexiglass plastic coffins. It was all they had. It was the lightest material. It was all they had that could carry a body. And so they're like, okay, we can at least get them away. We can launch them fast enough that they'll get out of this ship. And what happens is that Mission Control back on Earth manages to remotely control the artificial gravity on the ship, which is an interesting point. They flip the switch, but they don't tell them because it takes time to communicate with it too. And then they end up firing out. The artificial gravity stops. Everyone kind of floats up, including the coffins that are in this launch bay. And then the launch bay opens and they float out, but without any speed. So now they have no escape velocity. Their escape velocity is pretty much 0. They're floating out pretty slowly, such that I actually wouldn't be opposed to, outside of my artificial gravity caveat, not be opposed to them actually starting to orbit, because that's indeed what happens. They have almost a 0 escape velocity. They float out and they start orbiting the ship. And in fact, one of them got bumped as they were flying out, and it opened, and then we had a space zombie with his arm hanging out. I love this show. I think people are learning more about me than they are about the science, and that's fine. All right. I did try to calculate what the center of mass would be for these orbiting bodies, just to make sure they wouldn't be orbiting each other with the mass ratios. Again, mass ratios, we're totally fine here. It's 0.01 millimeters away from the center of the ship. That time I got the center of mass calculation correct. And they're orbiting at a speed of about, they're orbiting very slowly. They orbit about once every 90 minutes. And with the radius of the ship, that's, you know, they're, again, going fractions of meters per second. You know, maybe less than a mile an hour. They're floating around, which visually works for what we're able to see. Okay. So that's it for that. Oh, no worries. Hi, Purple Duck Boy. Yeah, we're talking about Avenue 5. Okay. You would think so, D Starfire. But Judd runs the company. This is a, I believe, a comment on capitalism as much as it is everything else. It is Purple Duck Boy. It's hilarious. It is a comedy. It's a very unique sense of humor. But if you stick around, you'll get enough of the sense of humor that you can decide if you want to watch it or not. I think we have a few converts in the chat already, so it's good. Now it's time for the wetsuit. We're actually flying through this. I don't think we're going to take the full 2 hours, but I'm here if we want to goof around and chat about it more. So, yeah, absolutely comedy of errors. Very good type comedy. It's brilliant. Comedy of errors. All right, the wetsuit. All right. They have their nice shiny bridge. They discover, and as was also quoted, it looked to be a gambling den underneath where the engineers who are not as visually appealing to the capitalistic view that Judd is trying to go for are the ones actually running the ship. The captain, who is also a fake captain, goes down to try to get to know all of them and get along with all of them, and they forget to vent the wetsuit. The wetsuit stands for, is a nickname, that's the word, a nickname for the sphere of human waste that surrounds the ship to protect them from solar radiation. I love it. I love it. And so essentially what happens is human waste doesn't get shot out of the ship until now. Doesn't get shot out of the ship. It gets pumped into the outside part of the ship and is part of the protection from solar radiation. So let's talk about that for a second. Solar radiation and radiation in general in space is very dangerous. When people ask me why we haven't been to Mars yet, what the limitations to us getting to Mars are, radiation is the first thing that I say, because we on Earth are actually very protected from radiation due to our magnetic field. The Earth has a molten core. That molten metal core is rotating, and that generates a magnetic field that protects us from radiation. However, when you're outside of that, you are bombarded with radiation. Now, would be a great panel for the science track. Now, I like this idea, right? The solar wind is very dangerous. So we talk about radiation from the sun. That where we're talking about high energy photons. Photons being light particles. So those are things like gamma rays, X-rays, ultraviolet rays. Ultraviolet rays manage to make their way a little bit into our atmosphere. Gamma rays and X-rays tend to not make it all the way through our atmosphere. So we're protected from them because of our atmosphere. If you're outside, you're not protected by them. And so those are a problem. You know, we talk about the fact that you can have, you can get skin cancer from ultraviolet radiation altering your chemistry. Absolutely true. However, solar wind is also made up of heavier particles such as electrons, protons, and alpha particles. Alpha particles are essentially ionized helium. Helium that's been stripped of its electrons, and then, yeah, electrons and protons, ionized hydrogen, right? Hydrogen is just a proton, so when you strip it apart, fling it, then it's a charged particle, and it's going very, very fast. So, Cusco, that's a good question. Does a solar wind hitting the magnetosphere slow the core's rotation? It does not, actually. I do like that question. because you do have to think of it all as kind of one system that we're looking at. But it's more of the fact that the magnetosphere is generated from the core of the Earth. And when the solar wind hits it, what happens is the solar wind and these charged particles hit our magnetosphere, and they kind of spiral. They get caught in that magnetic field, and they spiral up and they hit our atmosphere. They don't penetrate far enough to actually affect our core. That's a very, very good question. Yes, and as Mutant Bob mentioned, beta particles, very easy to block. Beta particles, no problem blocking them whatsoever. And yes, I'm going to get to cosmic radiation. So solar radiation, thank you for the transition there. So solar radiation is a decent problem here on Earth. And it's basically we have these solar events that fling these heavy particles out that are charged, that could be very dangerous to us, that our atmosphere and our magnetic field protect us from. When you're outside of that, you're going to get hit by them. But once you're out at like Saturn's distance, you're probably not going to be bombarded with solar radiation to the extent that you would need this level of radiation protection. What you do need protection from is cosmic radiation, as Mutant Bob mentioned. Primarily, we talk about galactic cosmic radiation. Cosmic rays, that was a word. Cosmic rays fire through our universe and our galaxy and our star system, and they do hit us. They do hit us. They pummel through. They're going super, super fast. If you've ever seen a cosmic ray detector, they're really cool. One of my favorite ones is at the Griffith Observatory here in LA. And you just see these like fires pop up. And what they are is that they're ionized particles. So when I talk about ionization of elements, you can take kind of any element on the periodic table from hydrogen to uranium, strip the electrons off of that, so you're left with this nucleus, and the nucleus is booking it. That's a really basic breakdown of what cosmic radiation is. But that booking it nucleus, when that hits you, that can actually strip, that can ionize particles. That can strip off these sort of outside elements that you have, or the outside electrons that you have. And that's a problem. That's not good for us. We want to avoid things like that happening. So galactic cosmic rays are a big problem when it comes to traveling throughout our solar system. And sure, D Starfire, if you want to imagine that galactic cosmic rays are going to turn you into a superhero, then by all means, go do it. I am not one to stop you, but I will tell you what it will do to your body before it makes you a superhero. But I still really like that take. So you're all good. Okay. So we have these nuclei of atoms that have been stripped away. They're flung through. There's lots of people who are studying kind of what the source of these are, but we detect them. And as far as we know, it's most likely left over from like supernovas. When stars explode and expel this matter, it goes, and there's nothing in space to slow it down. And so it eventually hits us. And again, because they're charged, we are kind of protected from them in our magnetosphere. Some make it through, but we do have some protection, but in space we don't. So we need some radiation protection. But these heavy particles, as was mentioned, are kind of easily blocked, especially the more massive ones, because they have size, they have mass, and so you can block them. There are probabilities that they can punch through, and then we still have high energy photons that are making their way through, so we do need some protection. And this idea of a waste shield has been proposed. Not just on Avenue 5, but yeah, exactly, D Starfire. Yes, and that's why Isaac Newton is the deadliest son of a bitch in space, because you fire stuff and it doesn't stop. This is Newton's first law of motion. It goes until it meets an outside force. And yeah, so this idea of water that we do actually use in the International Space Station. International Space Station is just in low Earth orbit, so it still has a little bit of protection from our magnetosphere, but not as much. And they have a portion of this, if I remember correctly, they have a portion of the space station that has a water shield that does protect them. Now, when this discussion has come up with respect to traveling to Mars, it does, it has a, but you're going to ruin someone's day. I can't not. Sorry, for people who weren't following that conversation between me and D Starfire, that's from Mass Effect, and it's a, Marine who's interrogating his troops with a lesson on Newton, and it's hilarious, about what happens when you fire in space and you miss. Okay. So using water is a decent shield. It's going to break up a bunch of particles, and it's going to stop them, and it'll protect you from that. But you can use organic waste too, and Mars is very far away. You're going to generate a lot of organic waste when you're going to Mars, and you can use that to your advantage. So that has been proposed. I think I did a little bit of digging to when I had first heard about it. It was about, I don't know, almost 10 years ago now, kind of early 2010s, where we were talking about that as an option for what we would do, and it's poop shielding. Yeah. However, there are some differences between what was proposed for those Mars missions and what we see in Avenue 5. Because the Mars missions, what they talk about is actually dehydrating the human waste, as we saw in The Martian, and reclaiming the water to be used. It's clean, it's fine. But then using the bags of dehydrated poop to line your wall. And that's still material, right? You're adding material to your ship, and any material you're adding is gonna help you. It's one of those, it's like, it can't hurt situations. What are you gonna do with it anyway? You might as well throw it in the walls to protect you from cosmic radiation. There's nothing wrong with this. Now, exactly, type. I love that. Okay, so water is a great shield as well, but we want to actually be able to reuse that. And that's where Avenue 5 kind of differentiates, because when they don't vent the waste system, which I also like, because waste generates a lot of gases. Gases increase the pressure, so it makes sense that you would have to periodically release the gases to prevent the pressure from building up. And build up the pressure does. When the captain is all having drinks with the crew down here, they forgot to vent it, and the pressure builds up, and you get a leak. And what's leaking out is not solid waste. It's mostly solid waste, but it is a combination of water and everything else. It's human waste. I looked up, I tried to actually science this a little bit more to try to figure out, like, what the organic waste would be made out of, and if it could have a difference on what you're protecting it from, and I walked away from that very quickly. There's a reason I'm not in biology. I started to feel kind of ill. I found pictures I didn't want to find, and I was done. So I'm okay with that. So what's clear, though, in this is that the buildup of gases, check. The fact that they're not dehydrating the waste to build their poop shield, it's not insane. It's not efficient, but we found that Judd is kind of dumb when it comes to this stuff, so that's okay. It doesn't make sense. They're not dehydrating it. When it does vent, it gets dehydrated. That water does evaporate away, as we saw when a chunk hit his helmet. I love this show. And it starts to orbit as well. And if I haven't sold you on the show yet, I'm sure that one will do it. Now, yeah, they essentially, they now have a ring of frozen poop that's going around the ship. Because they forgot to vent the gases. And they call it the wetsuit, or the turd cloak. I like that term too. That was a good one. And, yeah. All right. So it is, but regardless though, I do think, well, Paranor, I don't think it's necessarily too American humor, because it's very, most of the writing staff and the showrunner are British, Scottish as well. So there's a lot of Scottish humor, and it's very Armando Iannucci. Yeah, it's I would say it's not so much that it's not British humor, it's just Armando Iannucci style humor. So I can appreciate that it's not for you. Like I said, I caveated this when I started that it's not for everyone. And But yeah, I think if you stuck with it a little bit, you might see the humor sleep through a little bit. But I do appreciate that. And they're definitely trying to appeal to broad audiences here. And there is humor that crosses the board. Some of it's... I love it, but I love everything Armando Iannucci touches. So I hope he's not watching. If he's watching, hi. I'm a big fan. I really like your show. Yeah, because it's hilarious. Thank you, Kuzco. I was actually going to bring that up when I was watching it. I was thinking of this. I'm like, no one wrote a script to automate the venting process the second time. Yeah, the second time they had to do it. And so I love that. Yeah, it's so bizarre. It's, you would think so, but at the same time, they're bored. I mean, I have not automated processes purely because then I could justify my workday, if that makes sense. I'm like, I could write a script for that to remove time, or I can just take that 5 minutes every day to do this menial task and then justify that. So, you never know. Thank you. All right. So, poop shield, fine. Definitely reduces its effectiveness once it's outside of the ship and dehydrated and orbiting it. But as we saw, it was fairly opaque. We could see through it, but there was a lot there. So again, something is better than nothing when it comes to shielding from galactic cosmic radiation. It's important to have something there. So even if you just have a little chunk of frozen fecal matter that's going to stop a high energy particle from hitting you, that works. So I'm okay with it. And yeah, I like it. So let me see. Yeah, I mean, it's just its effectiveness. So it's less effective now that it's in space, but it's still doing what it needs to do. And frozen fecal matter. All right, so let's talk a little bit about dying in space and the way that they portray this here. Oh God, I love this show. So let's go back to the 500 people that they have to get rid of. They realize they can, then there's a whole plot that happens where they come back to needing to get rid of 500 NEPs or non-essential personnel. And they realize that they could get rid of the equivalent weight of 500 people. So they start gathering all of their stuff and taking it to the airlock such that they can vent out this and change their trajectory. They can get the funding and they can get home in 6 months is the full intent of what they're trying to do here. Now, ooh, domestic. I have not heard of that. That's cool. Thank you for the opportunity for a drink break. So real quick, before we get into the rest of that plot, when Joe died, Engineer Joe, in the first episode, he got impaled, very much like Mark Watney. And like Mark Watney, it froze over. He didn't survive. With the case of the Martian, it fired into Mark Watney and then lodged at an angle. It missed the vital organs, and then it lodged such that the blood that was coming out froze and sealed the wound. Brilliant. Love it. In this case, it impaled Joe there, so he didn't survive. But the blood did freeze, and then when they take it out, and it's not bleeding. They're like, well, what? They're all confused at what's happening, and then it immediately defrosts. That's great. That's brilliant. Space is cold, and it's a vacuum, and so it's very hard for liquids to survive. Hi, Shirna. Oh, thank you. I'm glad you're here. I'm very happy to be here. Yeah, I'm glad you were able to catch this. That's awesome. So yeah, the wound, or the blood around the wound immediately freezing. Great. Love it. Perfect explanation. Used to some, of the more gross comedy effect. I can respect it. So let's get back to what it's like to die in space. That's how Joe died. The way Joe died makes sense. He got impaled. It was instant. Hopefully. It seemed instant. They couldn't get a hold of him quickly. Yeah, there you go. In emergencies, human blood can be a makeshift sealant. Yeah. Now, series of events happen in the show, and we find out that, you know, Hugh Laurie is the captain, that he has no idea what he's doing. He's an actor. Engineer Joe was the only one who knew what was going on. And we have a crew of kind of rough engineers, and we love them. And they can manage to keep the ship together. But it all starts to fall apart pretty fast. And the crew, or the passengers, who are brilliant, by the way, the woman who plays Karen, and the Karen lexicon kind of came around the same time. So they wrote Karen before Karen was a thing, and Karen is Karen. It's the best way I can say it. But Karen was actually in Veep, or not in Veep. She was in the thick of it. She's a British actor. Please. Okay, so if you did watch that show, can we just appreciate for a second that the woman who played Karen is a British actor? She played the Prime Minister. Mind-blowing. She's amazing. Oh, no worries, Paranor. Thanks for being here. And yeah, so she played the PM in the thick of it. She plays Karen. Karen is fantastic. Sarah is one of the actors on the bridge who is also playing Sarah. And when Sarah is Sarah, no one knows who Sarah is. We love her too. And but they all start, the passengers are getting wind of, they never stop getting wind. Gossip travels nonstop, and Karen establishes herself as the liaison in the most Karen way possible. She's fabulous. She's fabulous. But I hate her, but because she's so good. And the passengers are sick of being lied to, and they see that the captain is basically fired. Judge fired him. He wasn't doing stuff anyway. And they see him out of costume, and it all breaks down real fast. In fact, I'm actually gonna pull this up real quick and share this with you. Because if you haven't seen it, it's worth just watching this one scene. This is the airlock scene. And you can watch it after this. But don't miss out on that. You can just search for Avenue 5 airlock scene. It's 3 minutes. It's a very stressful 3 minutes, particularly with everything that's going on in the world now, where we see human behavior at its worst. But what happens is that a woman who's part of the crew, or part of the passengers, she works in VFX, which stands for visual effects. I will say that every time because that's what the character says every time, and it's hilarious every single time. And the actress is Carrie Coughlin, and she saw my tweets, and she followed me on Twitter today. So, hi, Kelly. If you're there, thank you. You are brilliant as the VFX, stands for visual effects, person. She starts convincing everyone that this is a reality show, and this isn't real, and space outside is fake, and they're all being punked, and everyone's an actor. No one knows what they're doing, which is half true, but that they're not in space. And from her vent about this, they storm the airlock, and they, one of the guys stands in there, and he basically is just like, and they activate the airlock, and he gets sucked into space. And I will say, in fact, I actually have a picture of the second round of people that do this, which is hilarious. If you're a fan of Peep Show, the guy who plays Johnson is in this. I apologize. They go in there, and and it immediately kills them. Oh, there's that one again. Oh, nope, making them all appear. Nope, there we go. So good. So good. Now, no worries, you got it. So, I found that screenshot because it's my favorite moment. But the way they die in space, I'm not kidding. Okay, we've ragged on this a little bit. The 26-second thing doesn't work. The speed they're traveling, they're slingshotting around is, it works. Inciting incident, we'll let it go for the story standpoint. Poop shield, brilliant. We're good with that. This artificial gravity orbiting nonsense, we can actually get behind that. We can science it-ish away. The way they die in space, I swear, is the most accurate method of dying in space I have seen in any science fiction. And thank you. Welcome, Doctor Who, and thank you, Andy. I appreciate that. I swear. Because immediately, as soon as that door opens, they freeze and they explode. And it's horrifying. And the reaction to it is hilarious. But yeah, they're standing in the airlock, and then as soon as it opens and that air gets sucked out, and the nice thing too that I like about it is the airlock opens this way. So it starts to go down and you hear the air escape from it. So they aren't getting sucked out. The volume of the room, I'm going to be guessing, is about 27 cubic meters, like about a 3x3x3 room. So, you know, could the volume of the air in the room suck them out? It's possible. It doesn't for the visual effects here. I actually accidentally said that. For the VFX, stands for visual effects, it doesn't suck them out, but what it does is it kills them instantly. Exposed to the vacuum of space, their eyeballs and anything open explode and they freeze. And it's fabulous. Because I get the desire for science fiction to to play with that danger. You know, we've seen that in Battlestar Galactica. We saw it in Star Trek Discovery. We've seen it in a lot of science fiction where the character briefly gets exposed to the vacuum of space. Oh, we saw it in Aliens. Briefly get exposed to the vacuum of space and survive. And they end up a little bit messed up. I would say Battlestar Galactica did a pretty good job. Ooh, Sunshine too. Thank you. BSG did an okay job of it, where Callie was very much like she had to keep her eyes closed. She couldn't breathe afterwards. Her eyes were bloodshot. Like, they did a good job. Burnham, likewise, I think she was like struggling to breathe. They did a decent job with that. But this like instantaneous sort of pop that happens, where their eyes just hilarious and brilliant. I mean, yeah, so Mutant Bob, that's why I argue anytime I've like worked with shows or writers where they've been trying to write that in, I'm always like, close the eyes, because that's really hard to, a sudden vacuum pressure change with your eyeballs is not good. But if you can close your eyes, your skin is strong and you might be able to withstand that a little bit. But in this instant, with the multiple people we show get sucked out, they go and then freeze. I love it. And then the frozen blood too goes out, because but they did that. So the reason I think they did that so brilliantly was for the storyline of the fact that you had this woman here being like, I work in VFX. This is definitely VFX. I love too where they're pulling this stuff out the wall. They're like, this is a set. And he's like, no, we're just cheap. You know, it pulls it out super fast. And so it's tough. And I mean, we haven't necessarily sent a human. So X-Panther said there was a chimp that survived 10 minutes of near zero atmosphere and fully recovered in 2 weeks. That's bonkers. And y'all are great. But I don't know if you've ever done where your eyes are open, immediately going from that to that, so you're fine. What I do think is probably the least scientific of that whole thing was how quickly that room repressurized. Because as soon as that door shut again, I mean, we're talking seconds before another round of people forced their way through. And again, honestly, if you have no inclination to watch the show, that's okay. But grab that YouTube link and go watch that airlock scene, because it's just so brilliant. They do such a good job with it. And then they're all sitting there and they're like, they all look at that VFX woman, because it's terrible. It stands for visual effects. And they're like, do you still think it's a reality show? She's like, I'm on the fence now. So again, Kelly Coughlin, if you're here, I wasn't kidding. Well done. You brilliant character. Brilliant small character in that. Carried that episode. So it's episode 8. It's my favorite episode of the whole series. Okay, now, yeah, and it might be, thank you, Mutant Bob, for trying to look that up. it might be one of those cases too where it's like you can survive but not well. It's like saying tardigrades survive in space when really we sent up thousands of tardigrades and like 2% survived. Still not ideal. Not ideal at all. Okay. So the last thing I want to talk about, holding your breath makes it worse. Oh, that makes sense actually. That does make sense because you have nothing holding you down. So you have a pocket of air now that can expand. You want to have the fewest pockets of air possible when you're in a vacuum because they can just continue expanding. Yeah, like scuba diving. Smart. We smart. I love this crowd of people. So yeah, I love the dying in space scene. Love it. Like I said, I appreciate in science fiction when they have people exposed to the vacuum and survive. It's okay. It makes for a good storytelling dynamic. I think there's just some nuances to make it done right. And I swear this is so hilarious. And if you are under 18, I guess. But when he's doing that, that's so funny. And immediately freezes. Hilarious. Yeah, and bubbles in your, so yeah, definitely. So your blood boils. Your blood does boil in space because we do have oxygen pockets in our blood, and those start to boil. Space is brutal. You do not want to be exposed to it. And that's why I think it's because usually science fiction tends to err toward the freeze over aspect, as opposed to the blood boiling vessels popping type thing. And so the fact that Avenue 5 did both of those and made it horrible and did the VFX, the visual effects, so well that the actor or the passengers start to believe that actually no, they are in space. It's brilliant. It's so funny. It tends to err to freezing over. Yep. Okay, so let's talk really briefly about Newton's third law, which does get a nice shout out in this show. Newton's third law, action, reaction. Talked a little bit up front about how the inciting incident may not be physically possible because the mass is all a self-contained system. And so when you had the mass slam into the side of the ship to knock it off course, could that really knock something off course? Because is it truly a collision? And we didn't come down fully on no, but we're leaning towards no because it feels perpetual motion-y, which I fully agree with. So there's that aspect. But we let it go because that's the inciting incident and we're okay with that. But this idea of expelling 500 people's worth of mass, originally it was just 500 people, non-essential personnel, but 500 people's worth of mass comes into it, and they say, okay, well, what if we fired that weight out of the airlock, which we calculated is only 0.027% the mass of the entire ship. If we fire it out the back, that could give us the boost we need to get home sooner. It's going to increase their velocity, which is fair. It's going to reduce their mass, also fair. Science is very big. Those little changes make a big difference, so I'm okay to let that go, but it has to go out the back. Because as they say, I mean, very clearly, Hugh Laurie comes in with a great rant about Newton's third law. Action, reaction. It's got to go that way so the ship can go that way. It's got to go out the back. Babies know how to send stuff out the back. So they go that way. But there's a lot of confusion going on. 7 people just spaced themselves, thinking that it's a reality show. And Karen loads all of the stuff that they have, this 500 people's worth, which I equated to about 30,000 kilograms, assuming an average of 60 kilograms a person. Average. There's kids on the ship. So 300,000 kilograms has to fire out. She fires it out the port side. She doesn't fire it out the back. She just said the airlocks, they have them on the port side. There was enough room. Oh yeah, some pets went out. And she accidentally fired it out the left side. And that threw them more off course. And that's how the season ends, with them having a now 8-year journey that they have. And scene. So good. So good. Oh, Daib, I don't remember that. I love Venture Brothers, and I haven't seen that in a long time. I'll have to look that up again. That's hilarious. I love Venture Bros. Love it. That's such a great show. It is Gilligan's Island Space. It is Gilligan's Island. It's so good. It's so funny. And yeah, that's literally what happened. Ooh, if you, let me see if I can, let me see if there's an easy way to do that. No, that's my night mod. I can't approve links in here. So sorry. But if you tell people what to search for, we can go find it. Yeah, somehow everyone is Gilligan. Exactly. It's hilarious. And no one will listen to the professor, who is the engineer Billy, who's amazing, and we love her. No one listens to her. She doesn't get any credit for it. And between Karen, Judge, Iris, I love Iris, trying to just control Judd. And, oh, the humor is so good. Judd's just constant. When he's trying to explain where he has 2 protein balls, one is the ship and one is Earth, and he's like, if we come close, and then they're like, but they're the same size. And he's like, okay, so he eats what was supposed to be Earth and spits it away, and he's like, it gets all confused and horrible. It's hilarious. Yeah, so we didn't talk about escaping on the shuttle. I mean, it's pretty straightforward. Thing is that shuttle got there really fast. So we've established that their distance is not so far that you can still get there. They seem to get there in a matter of hours. That seems fast. Because they are, I guess, near Jupiter would be, what, 50 light minutes away-ish? What is Jupiter? It's about 75% of the distance. So if you're talking a trip of hours, I would say days is probably more realistic. Oh, lovely, Dipe. Awesome. Is that the quote from Venture Bros? I love that show. That's so messed up. Awesome. Thank you. I appreciate that. Iris. All right. Ooh, thank you. 36 light minutes. So yeah. Okay. So about 50%. That's right. I did know that. So yeah, 36 minutes. They get there in a handful of hours. It seems really fast, a more significant fraction of the speed of light, but they could have compressed time a little bit. They didn't throw any numbers out specifically with the trip between Earth and Avenue 5, so they can kind of get away with it. They had a lot of action going on the ship. Shuttle, not so much, so jumping between the two, that's okay. We can play with that. And, yeah, again, I tried to science a little bit about what expelling 30,000 kilograms out laterally from the ship would change its trajectory. It's pretty insignificant, and it's a little bit hard to tell with all of these. And actually, frankly, I was sick of doing momentum equations by that point, so. So yeah, so what they're trying to do now, the idea is that they're going to build this like this docking station with escape vessels that can actually get them out. And yeah, big difference what they launched it at. And we didn't get, they just vented all into space. And then they all are like screaming like, you sent it out of what? She's like, the port side, they have the airlock. She's like, you had to go out the back because of Newton's law. It goes that way and the ship goes that way. It goes out the back so you can go that way. And it's really funny. Oh yeah, that was a great quote, actually. Is that a good explosion? Well, we were in it. When he's simulating, trying to learn the whole story where the captain is the only one now because Joe died whose handprints are coded to be able to do some of the ship's functions. So he's trying to learn how to dock this ship and can't do it. And it actually reminded me a lot of when I was in space camp and I blew us all up because I forgot to open the payload bay doors when we went into space. Which we talk about air pockets in the vacuum of space. That's why. Was that a good explosion? Well, we were in it. So good. I love it. All right, so with that, that's pretty much all the science I had from all of Season 1 of Avenue 5. In conclusion, They play around with the science a lot to kick the plot off. We're not convinced that 5,000 people hitting one side of the ship instantly is actually going to throw it off course because it's a closed system. But without that, we would have no story. So we let that go. They are going fast, but they're not going so fast that they're breaking physics. They can get to Saturn and back again in 8 weeks without being a significant percentage of the speed of light. The artificial gravity on the ship can be remotely controlled from Earth. We don't know how it works. Doesn't matter how it works. It is some magical technology. But what we do know is that it extends beyond the hull of the ship somehow, because Joe felt the effects of the artificial gravity changing position. And that also helps explain how these coffins would get caught in the orbit, because the mass of the ship doesn't necessarily dictate a very big escape velocity that you would need to get away from it. But if the artificial gravity extends beyond the outside of the ship, then that could artificially change the mass, which would mean that you could still get caught in it. So we're okay with that. The comm delay of 26 seconds is not physical. That breaks the speed of light. But if we're going to play with the story versus science side of things, we're going to let that one go, because the comedy value of real-time communications with a 26-second delay is worth it. The delay between Earth and Saturn is actually more like 70 light minutes, so that's pretty tricky. Oh, I didn't talk about this. They have a comms blackout when they're behind Jupiter that's 8 days. That also is not physical, because the diameter of Jupiter is 139 million miles, and at the speed that they're going, it takes them only 4 minutes to pass behind Jupiter. So, they would not have a blackout of 8 days. They would have a blackout of 4 minutes, but we can play with that one a little bit. All right, so I got that one. Like I said, the escape velocity is not very high for this mass of a ship, but if the artificial gravity extends beyond that, then that can change the dynamics as well, so that's okay. The wetsuit is great. Scientifically, the idea that you would use waste. I didn't mention either that they do say specifically that the ship is only 18% self-sufficient. So the fact that they're not dehydrating all of the human waste does kind of make sense if it's only 18% self-sufficient. They maybe didn't want people, you know, part of the selling point for these people to go on a space cruise is that they don't have to drink their own water. And frankly, it makes a lot of sense that Judd would just not do that. That works for me. But it protects them from radiation in space. That would do it. Anything is better than nothing. And the fact that the human waste gets dehydrated as it goes into space is still not going to be much of a protector, but it's better than nothing. No worries, Panther. And the dying in space we loved. Joe getting impaled and then the blood freezing over and then defrosting once they bring him in is great. And then the fact that the airlock, the scene with all of them having their blood vessels explode as well as freeze instantaneously is pretty fantastic and ranks up there as some of the best VFX, stands for visual effects, that I have seen for how a human would actually die when exposed to the vacuum of space. And then Newton's third law. You gotta, if you want the ship to go that way, you gotta send the stuff that way, not that way. It's like the entire plot of the cliffhanger. So I love it. All right, so that was all that I had. We went long, obviously, and I appreciate you all being here. This is gonna be our last regularly scheduled episode club. I will be back on Friday at 1 p.m. Pacific time for Astronomy 101. You can check out my YouTube channel if you go to the About section down below. You can find all the links to my stuff. And you can subscribe to me on YouTube to catch up on previous posts. I will be posting this clip on YouTube. I know it's really, really long, but if you did want to go back and watch anything, you can feel free to go check those out. And then I will be back. So we've got Astronomy 101 on Friday. We have Star Trek Sunday on Sunday. And then we have, I'll be getting into my new programming schedule where I will be doing more games. Astronomy and Star Trek Brunch are still happening. So thank you all for the support. Thank you for being here. Super happy to have you all here. This was really, really fun. Thank you for letting me just geek out about one of my new favorite shows of all time. Because I love it. It's so good. It looks like Extra Credits is still live, so I might send you over that way. But you can feel free to sign out, feel free to say farewell, and I'm really happy that you were all here. So thank you again, and I will see you on Friday, and then keep an eye out for the new schedule starting next week. So thank you, everyone. I really appreciate it. Oh, thank you for the follow. All right. See you, everyone. Thanks. Bye.